All right, in this lesson, we're going to talk about binomial expansion. And what we mean by that, well, a binomial is any expression with two terms. So let's say a plus b. And by expansion, we mean if we're to take this to a power, let's say the fourth power, what would this look like if we multiplied this all out? And that's what we're going to do first here. So a plus b to the fourth power means we want a plus b times a plus b times a plus b times a plus b. So if we multiply this out, we'll multiply these two first. We get a squared plus ab plus another ab, so 2ab plus b times b is b squared. And then we've still got these a plus b here and another a plus b here. All right, now multiplying this times this a plus b, let's multiply the a's first. So this becomes a cubed plus 2a squared b plus a b squared. Then multiply everything by times b. And when I do this, I like to put these terms down below so that we can easily combine the like terms. So when we multiply b times a squared, we get a squared b, and I put that under that a squared b term. And then the next term will go here. B times 2ab is 2ab squared, and b times b squared is b cubed. Times a plus b. If we combine those like terms, we get a cubed plus 3a squared b plus 3ab squared plus b cubed, and multiplied by a plus b. So multiplying all of this by a, we get a to the fourth plus 3a to the third b plus 3a squared b squared plus ab cubed. And then everything times b gives us a cubed b plus 3a squared b squared plus 3ab cubed plus b to the fourth. And then adding our like terms, we get a to the fourth plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the fourth. All right, so there's our answer. And I'm going to leave that up here. But that is kind of tedious. And that gets really tedious if instead of a 4, say this were a 24, we wouldn't want to be doing this all day. So let's learn an easier way to do this binomial expansion. And I'm going to leave this up here so that we can see that when we do this easier way, we are going to get to the same answer. So starting off, we want to use something called Pascal's triangle. Pascal's triangle is just a sequence that is usually written out in this triangular shape. So if we start at the top, we'll start with 1. That's the first number in this sequence. And then to define this sequence, as we go down a level, we're going to add the two numbers directly above that number. So you can see here on either side of this 1, there's just a 0. So 0 plus 1 is 1. 1 plus 0 is 1. The ones are always, the numbers on the outside are always going to be a 1. So here, this third row is going to be, or the second row really, this is the 0th row. This is the first. The second, we've got a 1, and then 1 plus 1 is 2, and then 1. And then 1 plus 2 is 3, 2 plus 1 is 3, and 1 out here. And we get 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then 1. And let's do one more row. 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and then 1 on the outside. All right, so this Pascal's triangle It's used for several things, but for our purposes, we're going to use this to help us to do this binomial expansion. And so what happens is that each of these, this top row is going to be the coefficients for the binomial expansion of a plus b to the 0th power, And this is going to be a plus b to the first, a plus b to the second, a plus b to the third, a plus b to the fourth, and then a plus b to the fifth. And you can see that these numbers here in the second row are going to correspond to these numbers here that are going to be our powers. So if we're trying to do a plus b to the 4th power, our coefficients are going to be on this row here. So we're going to have a 1, and then a 4, then a 6, then a 4, and then a 1. And notice that when we do this, we always end up with this pattern of going from a to the 4th, a to the 3rd, a squared, a. That's always going to be the case. And so we're always going to start with this number here, this term to this number. So a to the 4th power. And then here we're going to have a to the 3rd power, then a squared, then a to the 1st, and then a to the 0, which is just 1. And then for the b, we're going to go backwards. So we're starting here at b to the 4th, b to the 3rd, b squared, b to the 1st, and b to the 0. And then all of these are added together. And you can see that this answer is the same as the answer we got down here. But we can get to this, once we know this pattern, we can get to this a lot quicker. All right. So now, if we want to find some particular term in a sequence, we're going to use the same type of thing, but instead of having to draw out Pascal's triangle every time we do this, the numbers that end up in Pascal's triangle are given to us by the combinations formula. So the combinations formula is this. If we're trying to find the number of combinations in n number of terms in r different ways, that's given by n factorial over n minus r factorial times r factorial. And there's actually a button on your calculator that will allow you to just put this in itself, or put this directly in, or you can use this formula here. The exclamation point is factorial. All right. So our binomial formula says that the rth term, if we've got a plus b to the nth power, and we're trying to find the r term, the rth term, then that's going to be given by n choose r, this combinations formula, times a to the n minus r power times b to the r power. All right, and there's our binomial formula, and that's what we're going to use to solve this example. All right, so we've got, we're trying to do the binomial expansion of 2p minus y to the 14th power. And we want the term, the p to the 4th, y to the 10th term. All right, so our binomial formula says that this, the 10th term, that's what we're trying to find. This is our r here. the power on this second variable. So we're trying to find the 10th term, and that's going to be equal to n, which is 14, choose r, which is 10, and that means the number of ways that you can arrange a group of 14 into groups of 10. So if we had 14 colored balls, how many different groups of 10 could you make out of those 14 colored balls? So, and then we're going to multiply that times p to the 4th power, 2p, because that's our a, this whole thing, 2p to the 4th power times negative y to the 10th power. So that's gonna give us our 10th term. So let's do this 14 choose 10. I don't have a calculator with me. You can just plug this into a calculator, but just to kind of show you what's going on, I'm going to do this without a calculator. So 14 choose 10 is going to be equal to 14 factorial, which is 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6. You get the idea. It goes down to 1 or to 2 really, because multiplying by 1 doesn't change anything. Over 4 factorial, which is 4 times 3 times 2 times 1, times 10 factorial, which is 10 times 9 times 8 times 7 times 6 times all the way down. And you can see that we're dividing here. These 10s are going to cancel, the 9s will cancel, the 8s. In fact, this whole thing all the way down to 1 is going to cancel. And so we're left with this. We can reduce this a little bit more. 12 over 4 is the same as 3 over 1. 14 over 2 is the same as 7 over 1. 7 times 3 is 21 times 13 is going to be 273. And then 273 times 11 is going to be 2,000. Let's see. No, 3,000. This is going to be 3, 10, 10, 3. 3,003. And then divided by 3 is going to be 1,001. All right, so 14 choose 10 is 1,001. And then we're going to multiply that by, so we get 1,001 times 2p to the 4th. 2 to the 4th is 16 times p to the 4th. So this is 16p to the 4th. And then negative 1 to the 10th power. Well, the negative number to an even power just becomes a positive. So this is going to be positive y to the 10th. All right, and then 16 times 1,001 is 16,016 p to the 4th y to the 10th. And we were just asked for the coefficient, so it's just this number here. That number there is going to give us our answer. So we start off with the this 14 choose 10 times all of this to that 4th power times all of this to the 10th power, and we end up with, this is our answer. 16,116 is going to be the coefficient on that 10th term in the binomial expansion in the expansion of this binomial.